Gut health is a topic which is taking precedence now on a global stage, and a lot of people are interested in it because, 1 in 5 people at some point in their lives will have gut problems, whether it's for longer period of time or whether it's just a day or a few days. It's also interesting that how quickly our microbiomes, the bacteria, can change and respond to things we do. So for those people who've got a, quote unquote, problematic gut, what is the clearest course of action they can take, and in what sort of time frame do you think they can realistically expect some change?
I think I'd always say, like, start off by, do go see your GP, do go see a dietitian. I think life is too short to be suffering with gut symptoms because there could be something going on. And usually most things you can solve through diet and lifestyle changes. When we're talking about your gut microbiome, what's so fantastic about your gut microbes, unlike your genes, you can change it. And we see that it can change in as little as 3 days. But of course, actually, it's really about those long-term consistent changes over months and years that really mean something when it comes to your gut microbiome. And I know that we both talk about this a lot, but it's what you can eat is a great way to support your gut microbiome, and particularly fibre, gut microbes' favourite food. And I definitely think the sexiest rebel nutrient out there.
Yeah, no, I agree as well. And, so personally, twice a year, I'll get some blood tests done, just privately, because I had a history of high cholesterol and a history of mild fatty liver disease, which I managed to turn around. So I'm still very keen on keeping an eye on various blood markers to make sure I'm still in the clear. And whenever I book those blood tests, I'm always, someone tries to upsell me on a microbiome test. And you recently touched on this topic. There was a recent global consensus from 69 world experts on the gut, microbiome, stool testing. And it wasn't a pretty read when it came to consumer grade microbiome testing. Can you talk a little bit about why maybe it's not as important or beneficial or useful for, the at-home consumer?
Yeah, so this consensus statement was really useful, right? Because I think it was, this collection of different microbiome experts from around the world. And they, pretty unanimously, 96% of them said, just this microbiome testing is just not really that useful for the everyday person yet. So, maybe just save your pennies. The reason for that is a number of things. So, your gut microbiome is this kind of evolving, very exciting, kind of complex community. It's a living, thriving ecosystem in your gut. So, what you're seeing when you do a gut microbiome test, where you effectively take a scoop of poo and you send it off to be analyzed, because in your poo is present lots of these different microbes. And so, you're getting a snapshot in time of kind of who's there. But the thing is, it's too simplistic to kind of say that, these microbes are quote unquote good or these microbes are quote unquote bad. Because, like you and I as human beings, we can probably be friendly in one situation, but we might have a bad day and act out in others. It's very much the same for our microbes too. So, we can see, for example, that certain healthy microbes might actually be in high levels in diseases. And likewise, the other way around. Or it might even just be that it's the same disease, but a different person, a different place that they live, and we can see it kind of responding in a very different way. So we've really shifted now more to looking at not really about who's there, but actually wanting to know what are they doing, what molecules are they producing for your health. And I think when you come back to these tests, they're showing you the levels of bacteria you have and which bacteria are there. But actually, kind of so what? It's not necessarily giving you, the science hasn't developed enough yet for us to be able to give you specific actual advice based on a test alone. And really, the actual advice is very much what we already know without needing to do a test. And I'd much rather people kind of save that money. And if you are wanting to spend something for your gut health, really focus on spending it on those really simple, actionable, everyday food items. Doesn't need to be expensive supplements, lotions, potions, none of that. I think, as you say, companies are very quick for kind of sexy marketing and wanting to upsell you. But actually, it's those core key foods. I talk a lot about what I call the BGBGs, which are like BGBGS: beans, greens, berries, grains and whole grains, and seeds and nuts and seeds. And actually, if we can focus on those and getting those as your kind of regular it doesn't have to be everyday, most day food items. That's probably one of the most impactful things you can do on a regular basis for your gut. But also thinking about what does that mean for you? That's like your energy, your mood, your focus, how you feel day to day. Like your health is right in the here and now and not just about warding off diseases down the line.
I think one of the biggest problems with these at-home tests also is the major conflict of interest that a lot of these companies have inherent in the system. Because, listen, I'm a bit of a data junkie. I like to know certain things, even if it doesn't make a huge difference in my day-to-day life. I just like to know what's a reading that I have, at this point in time. And so I would be open to looking at microbiome testing. But I think some of these companies don't paint themselves in the best light, because they sell you the testing and then they might sell you a personalized supplement based on a result they give you, which seems like a conflict of interest, which seems like I would be less inclined to trust the result because I'm being, again, upsold on an add-on, a bolt-on to that service. If it was just the testing with no further strings attached, that the process would be a bit more trustworthy. And for the average person, what is a good way to measure your gut health beyond just looking at the toilet?
Oh, you stole my line there, because I think you should just look at
Okay.
the toilets. I think that's really where we should all be starting. I think, we should be. It amazes me that, time and time again, people will say they just are scared of looking at their poo. And your poo is your kind of best measure for how healthy your gut is, because it's not just your gut microbiome. You've got to think about the home of your gut microbiome, and the home of your gut microbiome being your gut. And we know that, like we do, if we have a nice, clean, fresh, kind of airy home, we tend to be, the cupboards are stocked. We tend to be pretty happy. We tend to be thriving in our environment. So yeah, I think let's start with the poo, because I think let's just talk about it. And I talk about poo. I'm not going to talk about bowel movements or stools or anything like that. I think we just need to call it what it is. Everybody does it. Kim Kardashian does it. So there's really 4 key things that we want to be thinking about when we're taking a look at the toilet bowl. We want to think about how often you're going. So any time between 3 times a day to 3 times a week. That's kind of healthy. And obviously this is your bread and butter too. So that's quite a broad range, but you want it to kind of be consistent within that range. So if you're having kind of a significant deviation from your norm, that might be something you just want to kind of, maybe take a visit to the GP, just double check. Always better safe than sorry. The second thing you want to be looking at is the color. You want it to be like a dark brown. And if it's kind of red, maroon, kind of blackish, that could be the sign that's blood present. Again, that's something that is just good idea just to go and get checked with a GP. And then you're wanting it to be a smooth sausage, or a sausage with cracks in it. That is a nice, healthy poo shape. If it is kind of mushy or it's pebbly, simple few lifestyle and diet changes can just usually be the kind of solution to that. And also fibre kind of works both ways, kind of good for both. And then the last thing is, how are you feeling? So is it taking you ages to go to the loo? Does it feel incomplete? Are you feeling any pain or discomfort? And I think a key thing also I really like to flag when I talk about this is that, we really kind of catastrophize around bloating. And actually having bloating in that kind of first kind of hour or 2 after a meal is totally normal, and actually could be a sign of a healthy gut microbiome, because when your gut microbes feed on their favorite food, which, particularly fiber, they, yes, produce these beneficial kind of healthy molecules, but as a side effect, they're producing gas. They're kind of a bit tutti and fruity. So having a little bit of bloating, particularly after a kind of high fiber meal, is actually, probably a good thing. Go for what is a good thing. Go for a fart walk. If you're feeling uncomfortable, undo your trousers a little bit. Just feel satisfied that you've thrown your gut microbes a bit of a feast and a fiesta. So that's something to not worry about. But of course, if you're having bloating that is staying raised and consistent and it's feeling incredibly uncomfortable, that could be a sign, again, there's something going on. But then if we're talking more broadly about how might you feel with the gut microbiome, we then kind of reach into more of a kind of slightly kind of nebulous regions where, the kind of symptoms that could be applied to many different things and not necessarily very specific to your gut. So things like fatigue, low mood, Your immune system might be a bit kind of low because we know that 70% of your immune cells live in your gut. So lots of kind of other aspects that, are tied to how you feel from your gut health. So really that best measure is really just taking a look in the toilet bowl.
Yeah, I think probably the best proxy we have for the health of your gut microbiome for an at-home test for an avid data tracker would just be looking at the toilet bowl. And I really don't know why people are so embarrassed and ashamed of looking at that. I love looking at my toilet bowl every morning and seeing what my body has produced. And I think the next big breakthrough will be those smart AI toilets, which will take a snapshot of your stool, use AI to generate some outcomes, track it. So, you'll essentially have an Aura ring or a Whoop for your poop. And I think that will be the next sort of big gut health tracker. And I definitely will be an early adopter of something like that. And something you're working on at King's College London right now is looking at the impact on the gut microbiome of a high fiber whole food diet, particularly looking at metabolic markers, inflammatory markers, and how that correlates to bowel cancer risk as well. That is such a hugely important topic because we keep hearing scary headlines and very real headlines as well that we're seeing rising rates of colorectal cancer in young people under 50. And we know that colorectal cancer is the third leading cause of cancer in the world, and it's the second leading cause of death globally as well. So, it is a highly treatable cancer in terms of surgery, chemotherapy, radiotherapy. Early screening can save lives, but also its incidence is also pretty high and it's pretty commonplace as well. And there are a few things we can pick out. But beyond the screening and what you can do once you develop bowel cancer, there's a whole host of things you can do beforehand. And that's where you're trying to look at, that puzzle and trying to figure out why this is happening. So can you tell us a little bit more about that trial?
Yeah, so we have, we were awarded £20 million worth of funding for a kind of
Wow.
collective 5-year project. Yeah, it's very, pretty amazing. And it's led by Harvard. It's a kind of multi-institution research project. And the aspect that we're working on at King's is looking at a diet intervention and seeing how that potentially changes what we think might be potential levers when it comes to bowel cancer, but particularly bowel cancer in people under 50 years old, where really the whole research project is very much geared towards bowel cancer of people under 50, because we're seeing these kind of rising rates in people under 50, where actually in many countries, actually it's kind of staying stable in people who tend to get, in the past who have more commonly got bowel cancer have been older people. And so we think that there's a different driving factor here and kind of wondering why that is. And just to put that into context, if you were born in 1990, you have, you're related to having kind of twice the risk of colon cancer, so the cancer of the large intestine, and 4 times as more likelihood of having cancer in the rectum, so that last bit of your digestive pipe, than if you were born in 1950. So that's like this really kind of big shift that's happening there. So we're kind of seeing, again, there are the other differences. For example, that if you're getting bowel cancer when you're younger, it tends to be kind of more common in different parts of your digestive tract, so more towards the end of the large intestine. We're seeing that perhaps it's kind of progressing a lot more rapidly. And it's really bringing signals that, okay, we really need to understand this a bit more. So that's really what the whole kind of collective research project is trying to understand more about why this is happening on people under 50, because most of the evidence that we have at the moment is in that kind of, that group of people in their 70s that have historically been the ones who have got bowel cancer. So we're looking and focusing very much on fibre and thinking about the microbiome as perhaps connecting the dots here. So we're thinking about not just kind of, should we be having more fibre? So the recommendations in the UK at the moment are kind of 30 grams of fibre a day. Actually, most of us are not meeting that. We really have this kind of big fibre deficit. On average in the UK, we're eating about 20 grams of fibre. But we don't actually have many studies out there looking at whether is it even having more fibre actually more beneficial? Should we be having 40 grams of fibre? And then also thinking about where are we getting that fibre from? Should we be getting kind of lots of different types of fibre? We know that that's really helpful, but in terms of the kind of this early bowel cancer, what does that mean? And we see, in other studies that there's different kind of risk related to bowel cancer depending on kind of that food source of fibre. So we see that, for example, whole grain sources tend to have a kind of a lower risk of bowel cancer than perhaps kind of cereals or fruits. And that could be because these whole grains tend to be really kind of rich sources of what we call insoluble fiber. This is a fiber that helps to kind of bulk up your poo. And that's particularly important for that kind of last part of that colon when you're kind of getting to that kind of poo packing factory stage. It's kind of helping to bulk up your poo, but to help make sure that everything's moving through and shifting out. So that's something that has kind of informed kind of what we're looking at in many ways. And then again, this piece with the microbiome, really interesting research around that we see in mice. So these kind of early models that we're wanting to understand whether that matters in humans as well. So thinking about kind of, yes, there are certain kind of types of microbes that seem to be coming up more regularly in people with bowel cancer. And is that just a consequence of, that disease, or is it just that that's something that is actually triggering a reaction and could be an element that is at play here?
So I think there's lots of different facets of this to unpack. But, first of all, just reiterating something you said, which was very scary. If you're born in 1990, you have twice the risk of colon cancer and 4 times the risk of rectal cancer than if you were born in 1950. So I was born in 1990. That's obviously worrying on a personal note, and probably for a lot of people, 90s babies, that's a very worrying statistic. And, compared to the 1990s and now, and if you look at the 1950s, sure, there was urbanization and industrialization in both of those eras, but there has been huge shifts in the food environment, between the 1950s and the 90s over those decades. And I think one of those things is the availability and abundance of food. Maybe 1990s onwards, people are more likely to overconsume compared to the 1950s, just, the scarcity of food potentially, in relative terms. But also one thing, going a step backwards from the food abundance, the soil, the quality of the soil as well, and the sort of density of nutrients in the soil, and how that might impact the fiber density and the nutrient density of the foods. I don't have specific statistics, but if I had to guess, and an educated guess, I would suspect the same corn cob or the same carrot in the 1950s may have had more types of fiber and more fiber in total, like for like, than the same produce in the 1990s.
I think it tends to be one of those things where there's never just one key thing. It's like all these multitude of things happening. We know that obesity is a risk factor. Likely, as you say, there's some kind of loss of nutrients. We also see that younger people tend to have a kind of lower quality diet, so basically a less healthy diet than kind of older adults. And then we also have to think about other factors that aren't necessarily food as well, and thinking about things like microplastics in the environment and, seeing that there seems to be a link there. When it comes to the microbiome, there's been really interesting papers coming out. This is really kind of hot off the press, really in the last year. We think there's a kind of key group of microbes which are called PKS positive E. coli. So E. coli, we get suddenly like, oh God, I know about that because it's, food poisoning. But actually most of E. coli are, they're very commonly present and completely friendly and harmless. But there does seem to be this group which effectively contain a kind of cluster of genes. So this is a kind of PKS positive part, which can make a toxin called colobactin. And it's this colobactin that we're kind of quite interested in, which we see in mice, can actually and seems to kind of be related to having a low fiber diet, that we get this kind of, these microbes then end up kind of acting out and they start kind of feeding on that protective kind of mucus layer which lines and coats your gut a bit like a kind of comfy warm duvet, and then can then perhaps produce produce this damaging toxin, which can then damage the DNA of some of the cells. And if that's then happening on your gut, that repeated DNA damage, that could then proliferate into tumors. And there was a kind of research group looked at people who were under 40 and found that this kind of signature of damage was 3 times more common in people with bowel cancer under 40 than it was in people above 70. So again, could it be that, there's a difference there? There seems to be something going on in terms of the microbes and that damage. And then can we link this to understanding, is this a diet factor? What's happening here? So a lot of unknowns at this point, I'm afraid. But I'm really hoping that, this is a 5-year project, and there's lots of other research groups working this, and we're hoping to really find something that's useful and impactful. And I'm sure we will, as, lots of different institutions involved.
So microplastics and the gut, I think that's an interesting thread to pull, because there's growing evidence, and it's accumulating pretty fast, that whilst we can't prove causatively yet, I think there's still, we need convincing causative proof that microplastics are directly damaging us. There is a ton of correlative associative data that microplastics are unlikely to be good. And in fact, they are most likely bad for our health, for our metabolic health, hormonal health, mental, cognitive health, everything. And, the gut is next in line, clearly. And if we look at our era right now in 2025 and compared to decades ago, clearly there's a lot more microplastics and nanoplastics in the environment, in the air, in the water we drink, in standard, even healthy food that we eat on a day-to-day basis. The consumable of single-use plastics has, skyrocketed like nothing else. What is actually going on? Is it the direct impact of, because, plastics are inert. So is it some inflammatory response they provoke in the microbiome and the microbes that then cause pro-inflammatory chemicals to leak into our bloodstream? Or what is actually going on? Because, if I swallowed a piece of plastic right now, it's going to go through my gut undigested. But clearly along the way, it'll have some interactions with things on a microscopic cellular level, which, we can't speak to what happens, and it may be bad.
So I think there's a few, I'd say probably there's early research, so we're not fully sure exactly what's happening. But I think what we're seeing at the moment is that, as you say, they're passing through your gut, but they're potentially interacting with your gut microbes, and your gut microbes, potentially then feeding on them, and then they're making these potentially damaging molecules as a consequence. But it could also be that they're also getting embedded in the kind of gut lining as well. I'm seeing that there seems to be studies that show that there may be higher levels of microplastics like within kind of tumors. But again, this is like really early stages of research. And part of the reason for that is that we haven't really had the technology to even profile, what microplastics, nanoplastics to that scale are even present. I do want to share something though to kind of ease people's mind in terms of that stat around, I'm sure everyone's heard this, we eat a credit card of plastic a week, or whatever time frame. I think it's a week. Actually, researchers did take a look at that, and they found that was like wildly overestimated. And actually, to eat that quantity of plastic, it would take kind of thousands of years. So that, I think it feels very scary. But again, we are seeing accumulations of microplastics, in many different sites of the body, including the brain as well, in comparison to kind of years previous. So that could be, a key factor that's also contributing to this. But again, more research, and hopefully, we'll have more answers in that in the coming years.
It's interesting because although there clearly isn't an abundance or any studies proving this, but there's some recent evidence that's come to light suggesting that there are certain types of fibers like beta-glucan found in oats and barley, which can actually bind to microplastics and chelate and bind them and help to excrete them from the body. So, a simple solution to reduce microplastics to whatever end that will be might be a simple dietary intervention like eating more fiber. And then, we know fiber has this role in reducing colorectal cancer risk, whether it's restoring the gut barrier integrity, reducing the amount of colibactin, various other beneficial things they do. Potentially a role which is worthy of investigation is what is the impact of this increased dietary fiber and how it reduces the burden of microplastics in the body, and what downstream benefit does that have, and what is the contribution of microplastic reduction and then that contributing to colorectal cancer risk reduction. I don't know, that's a pure hypothesis there,
but it makes complete sense, right? Because if we think about really, very simply, when we're talking about fiber, it helps improve what we call the gut transit time, which is effectively just a fancy word for how long food takes from when you eat it to go through your digestive system and come out the other end. And it helps to give you that kind of Goldilocks zone of like not too fast, not too slow, but making sure that food is moving through. And so inherently as part of that, it makes sense that if you are consuming microplastics, it's then not hanging around too long to then be damaging. It's kind of you've got a system, it's continuing to pass through. So that makes sense, I think. And it's just that, yeah, we need to know more. And I think what's difficult about the microplastics is that it's everywhere. We can't avoid them. And there are some small, simple things we can do. I think what's particularly useful is perhaps actually focusing on your water intake. So we tend to ingest our microplastics from food or drink, which makes sense, right? And actually by kind of filtering your water, that can help. Actually, even something as simple as boiling your water has been shown to kind of reduce how many microplastics in, because they kind of sink to the bottom. And then the biggest kind of crunch is actually just avoiding bottled water, because we see with kind of bottled water, you then there's like much higher levels than there are even in tap water. So, just if you're feeling like you're got a kind of plastic water bottle, even just swap it out for something that's maybe metal instead, and using that. So kind of simple, actionable things.
I think there's a lot of these factors which we as individuals are able to manipulate to lower our risk of chronic disease, cancer, various other disorders in general. But I feel fundamentally there's a big problem with public health policy because, and the problem I envisage there is the emphasis seems to be too much on individual blame. Things like you need to stop smoking, you need to cut down on alcohol, you need to eat more fiber, you need to get more movement. People know that. People know they need to stop smoking, eat more fiber, get more movement, control their stress levels. I don't think that messaging right now is as helpful as it was maybe 20, 30, 40 years ago, because there are real drivers and levers that governments across the world can pull, which they're not pulling, because there are some modifiable risk factors which we as individuals can't modify when it comes to these influencing factors on our gut microbiome and eventually our health. Like, for example, air pollution and cancer risk, urban design. We know that our environment shapes our microbiome. So if we're constantly exposed to smoke and pollution and toxicity in the air, that's going to in fact impact our microbiome, which will impact our cancer disease risk and other diseases as well. So I think there's simple things that the government can do. I mean, maybe it's not simple, but I feel that looking at air quality, looking at urban design, pollution reduction, and atmospheric quality, maybe those are things which need to be taken, into a greater consideration than just putting the blame on members of the public. Because whilst they're not blaming the public, that's what sometimes I think public health policy can feel like, where it's apportioning responsibility and burden almost to members of the public. Like, you need to do these 10 things prescriptively to improve your health and reduce your cancer risk. But then what about these things which I can't do? I can't control pollution levels on a microscopic level. It needs someone, top-down change. And we know, the gut-lung axis, there's a direct interface between the air we breathe and the environments we're in and how it shapes the immune system and then the gut microbiome as well. And I wonder how big a risk factor that is also for the rising rates of cancer, because, pollution's only got worse over the years.
Absolutely. And I think you're so spot on there that we need more kind of public interventions. I think the difficulty is that these things tend to take 10 years, and then it's difficult for them to know, is this, or longer, is this because of this intervention? Because there's so many different contributing factors. They all need to be happening at the same time. But I think even, looking at the stuff that we feel that we do have control over isn't always necessarily the case. So I think thinking about food choices, for example, how we are kind of very much subconsciously manipulated by our environment. And I think a really great example of this is when you go to the supermarket, there's something called nudging based on where they kind of put the food products. That's all about kind of manipulating you into walking down certain aisles, picking up certain food items that you feel that you are in control of. But actually, we're picking up so many signals subconsciously that is having a direct influence. A great example of that is, next time we go to the supermarket, where are they placing the eggs? The eggs are always at the very end of the supermarket, down the aisle of where, the crisps, the sugary drinks are, all those things at the very end, because they want you to walk through. They want you to see the buy one, get one free offers. And they want you to kind of pick up these things and put them in your basket. Same thing at the checkout desks. They know that you're standing waiting. Oh, I've just seen there's a chocolate bar there. And I think, again, how many aisles do we have in a supermarket that are fresh produce? Maybe one, max two, and then what's the rest of the supermarket kind of made of? And it's all kind of brightly colored advertising. So lots of manipulation happening on many different levels that is influencing our food choices, so many things that we don't necessarily have ownership of. And yes, we do have some, some conscious choice, but it's really recognizing the environment. We see this time and time again. It's the world we live in that shapes, such a significant amount of our health. And also thinking about not even that, just that, it's the socioeconomic differences. So lower income and the impact of that on health, such a key in that disparity, that difference between, if you're lower income to higher income, that is something that, governments, that was probably one of the biggest things governments can do in terms of supporting population health.
Something I think which is very underrated, in addition to what you've mentioned there, and I don't see a lot of people bringing it up. Certainly, when you go to your GP or when you sort of just read about things about cancer risk reduction online, you don't hear about this. But if someone wants to reduce their risk of bowel cancer, I think an easy place to start with that risk reduction may be in the mouth, because we're getting more data about the oral microbiome. And I think there was even a couple of studies that show that some pathogenic bacteria like Fusobacterium nucleatum, which is often associated with periodontitis and gum disease, those same pathogenic bacteria and the carcinogenic compounds they produce were found in cancer polyps in the colon, in the large intestine. So, those same bacteria found in the mouth ended up in the intestine as well. And it sort of makes sense because the mouth is the beginning of the GI tract. So, it's one long continuum and one long spectrum. But, I guess simple things like flossing, brushing twice a day, just taking care of your gums in general, and minimizing sugar intake to a degree without sort of restricting it, that might be such an underutilized tool. And even getting regular dental checkups, because whilst we can't quantify, if you do this to your mouth and your oral microbiome, you will experience this degree reduction of bowel cancer. It's one of those things which is essentially zero cost and pretty easy for someone to do, and doesn't require a whole lot of thinking, just it needs habit formation. But again, you're looking at these cumulative bonus wins. Where can you pick up a couple of % risk reduction doing simple things? And I think starting with the mouth seems like one of those things.
Yeah, it's a really interesting point, because Fusobacterium nucleatum, as you say, I always get to call it Fuso for short. You've got to give them like fun names, even though it's problematic in the gut. And we do see it in the gut consistently coming up with a kind of microbiome with lots of other microbes as well, a kind of signature that seems to be related to bowel cancer. And yes, actually, most healthy people, it shouldn't be present that much in the gut. And actually, it's a very common kind of microbe in the mouth. And just, it's totally normal to have fuso in your mouth. It's just when it's in too many levels, it then becomes problematic in your mouth and then becomes kind of related to something that could be an issue, that kind of buildup of plaque. So everybody will have fuso in their mouth. That's not something necessary to worry about unless it's getting to these bigger volumes. This is something we're also thinking of maybe collecting in our study, is to collect swabs from the mouth to see whether that might be a kind of early kind of risk thing that we can catch in people who are healthy before maybe there's theoretically this like downstream approach. And it could be that we're either like swallowing, there's a buildup and accumulation that we're then swallowing, and then it's then starting to proliferate in the gut. Or it could be, and this is kind of quite interesting, so it's not just relevant to bowel cancer, but when the gums get inflamed, we're seeing kind of early signs that perhaps then problematic bacteria are then trespassing into the bloodstream and then causing a kind of inflammatory reaction. And that kind of inflammation is, they're looking at signals with, for example, Alzheimer's and kind of brain diseases as well as being potentially related to kind of overgrowth of bad bacteria in the mouth.
When we look at microbiome research, and we've got so much data pouring in on a weekly, monthly basis, but it seems the world's population is underrepresented when it comes to all of this data because it's primarily derived from developed countries and affluent countries and usually Western populations. I feel that the microbiome of Africa, for example, and other places in the world where there may be large groups of non-industrialized cohorts of people, there could be a lot to unlock in those populations, which could help us unlock some secrets of the microbiome. Because we know in so many rural populations in South America, Asia, Africa, when people do eventually go and do some analysis on these populations, they discover bacterial genomes with new functions or even species not seen in other populations. And then what impact may these novel things have on disease risk and, what it may do. And I wonder, why are we not sort of looking at more of those populations and seeing what we can uncover in terms of how to reduce our global health burden?
There's been some work around that, and I think we can always do a lot more. And I think we've got a caveat with the fact that sampling people's microbiome is incredibly expensive. So I think this has historically been a huge barrier. Now we've got better technology, those prices and that cost kind of barrier is coming down for researchers. And so it's becoming a lot easier for people to, include that in the money that they're kind of receiving their grants for research funding. So again, something that hopefully will escalate. But we've seen, for example, some research done on the Hadza tribe that in Tanzania, they've got this, it's kind of the closest we can see to maybe an ancestral microbiome because they're, foragers, they're outside all the time. They have this really diverse kind of fiber-rich diet. And so in comparison to our guts in the West, which are kind of, we're our urban environment, we've, have poor quality diets. We think that in comparison, we've lost about 124 species, could be more. And actually that, is happening generationally. We see in mice studies that, there's, from each, if you're having a kind of poor quality diet, that then gets passed on, you've got your mother kind of seeding microbes to its kind of newborn when it's born. And then there's this like progressive generational loss that's happening. And we had this recently, this new study that came out kind of early this year called the NEMI study, which looked at whether you could potentially restore your gut microbiome. What they did was they found a probiotic, so a kind of quote unquote kind of good bacteria shown to have kind of health effects that tends to be common in populations that are kind of living this kind of non-industrialized life that we just don't see in Western populations. And they gave them, a dose of this probiotic and then had them on this high fiber diet. So it was a kind of 45 grams of fiber. And also within this diet, they made sure that there were certain types of fibre that would kind of feed that microbe to help it kind of flourish. We know that, you want it to be well fed for it to kind of stick around. Sadly, not so excitingly, that microbe in most people just didn't hang around, despite it, apart from one person it stuck around in low levels. Curious to why that might be. And I think this again shows that everybody's microbiome is very different. But at least, the positives from that is that even just having that high fiber diet, they saw really beneficial changes to those kind of molecules it produced. So still showing that no matter the microbes you have, you can help them to do great things for your health, but actually being able to repopulate with, a microbe of choice is perhaps a very difficult thing. Not to say that there won't be, other different types of microbes, and maybe that will be successful, but it's not as simple. And I think we have, it's something that could explain one factor of why we've got, higher rates of kind of diseases related to, inflammation, more kind of allergies, more autoimmune conditions.
One thing I'm really interested is the link between gut health, the microbiome, and general brain health, neuroprotective benefits, and also, negative effects on, the brain and mood disorders in general. And, there's some interesting data that keeps coming out. Like, for example, individuals with ADHD are 63% more likely to experience IBS than those without ADHD. So there's a clear link being established in the literature between neurodiverse conditions and gut microbiome dysbiosis, or some changes compared to someone without neurodivergent conditions. And it's interesting that those with ADHD also report more constipation, bloating, flatulence. And I wonder, is our current paradigm of mental health treatment of neurodivergent conditions, is it just focus on medication and neglecting lifestyle factors, namely microbiome modulation, as one of the adjuncts to treatment? Is one of the many root causes of complex mental health conditions, neurodivergent conditions which involve the brain. Are we neglecting a huge piece of the puzzle by not focusing on gut-directed or microbial-directed therapies? And we're just overly focused on just medication alone.
I think there's always usually room for bringing in other tools, into that toolkit, and how impactful those tools will be very, very dependent on that person and what they're looking for. We do see that in people with ADHD and also kind of autism as well, that they tend to have a very different gut microbiome. But whether that is, a kind of what we say, kind of causal factor, or just like a consequence of that person and the life they live. We know, for example, with autism, that there's kind of usually quite a significant difference in diet there, that there's very kind of real huge difficulty in having a diverse, colourful diet. So is it just that that's actually a consequence of having this diet? But again, we do, in kind of my studies where they try and kind of model these, we do see certain probiotics potentially just helping to just ease some of the symptoms. So some of the kind of dials that you may want to turn kind of down a little bit. So things like, just being able to help with stress and sleep, things. So I think we'll know a lot more about that and what's coming up. I think there's kind of interesting research that's coming into this space. When we're looking at mood, that's a really interesting one as well, where, for example, depression, we see that people with depression have a very different gut microbiome. We also see that they have lower levels of short-chain fatty acids, so really kind of helpful for your blood-brain barrier. And these are kind of molecules that are produced when your gut microbes kind of feed on fiber. They also have a kind of anti-inflammatory effect. And there was kind of a lot of kind of discussion, in kind of the early days around, again, is this just a symptom? Because we know, and anyone can relate to this, because mental health's on a spectrum, that, if you're feeling pretty low, you might end up just being like, I'm going to have that thing that's going to give me comfort, whether it's kind of, chocolate cake or whatever it is. And you might end up just having overall a lower quality diet, and that could then be impacting. So which way is this going? 2014, really interesting study from researchers in Ireland, so APC microbiome, and they effectively took fecal microbiota transplants, so a poo transplant from people who were clinically depressed, and transplanted that into rats. And what they found was that the rats then started to kind of exhibit these kind of depressive-like behaviors. So we're seeing that actually there seems to be this connection where there is perhaps, a piece in the puzzle where the microbes are definitely having an impact on your mood state, that we just need to see more and more kind of evidence to kind of support this, whether this is actually is holding true. What we think is that your microbes are kind of talking to your brain in many different ways. They're talking directly through what's called your vagus nerve. This is a long wandering nerve that connects your gut to your brain. So they're kind of tapping in, tuning into that, picking up the phone to your brain. They're producing molecules like those short-chain fatty acids. Short-chain fatty acids are important for your blood-brain barrier and also for your brain. They're also interacting with your immune system. Your immune system is constantly sending messages as well, but also through your neurotransmitters, so things like serotonin and GABA. What has been kind of very common and popular is people kind of distilling this into a very simplistic format, and it ends up being kind of, we're getting like way ahead of where the science is at. And a key thing I hear people say time again is, 90% of your happy hormone serotonin is made in the gut. And that's slightly kind of right but wrong in so many ways. And let me explain why. So yes, 90% of serotonin that is made in your gut, but actually that serotonin is too big to pass through your blood-brain barrier, which is like a fortress around your brain that, has gateways that kind of lets helpful things in and keep things out. So that serotonin that's made in your gut can't pass through to your brain. It's actually helping with what we call your gut motility. So how easily things are moving through your gut. It's very much having a digestive role, because like so many things in our body, all these things have many different jobs. It's not just the things that we're like simplifying it to. But we do think that serotonin is likely still having a kind of knock-on effect on mood. But actually where the microbes might be playing a role in terms of serotonin with our mood is they're helping to supply that early building block of serotonin. So tryptophan, which is an amino acid, they're helping to kind of manage how tryptophan is used in the body, and therefore how your brain has access to this tryptophan, and then in your brain can then make it into serotonin. So I talk a little bit like it's the difference between ordering a sofa that you cannot fit through your front door versus getting the flat pack furniture. So you need to get the pieces in first, and then it gets made in your living room. So that's kind of the difference there.
I feel there's a lot of similarities between microbiome science at this current stage and neuroscience, where it's fascinating. We know it's vitally important for human existence, but it's so hard to understand. And I think the more we peek into this mirror, which is the microbiome, the more questions there are going to be thrown up. And I'll be eagerly waiting over the next few years the results of the fantastic and vitally important trial that you guys are doing for global impact, and all the other science and research you churn out about the microbiome and gut health. So Emily Leeming, thank you so much for joining me.
Thank you. So great to be here. It's great to chat with you.